the sky appears calm. There are no flashy maneuvers. Yet this week, a next-generation stealth drone successfully completed its maiden flight. This flight test marks the first step in a series of official evaluations that will define the future of unmanned aerial surveillance systems. It's not about speed. It's not about weaponry. It's about who sees first and who realizes it too late. Behind this single maiden flight lies a new trajectory for advanced stealth drone technology. By the end of this video, we will understand why the role of the eye in the sky is now more decisive than ever. A milestone in aerospace. In recent days, the aerospace world recorded a significant milestone. A next-generation stealth drone reportedly completed its inaugural flight. This event signals the beginning of the official flight test phase, following years of behind-the-scenes development. Developed by a major aerospace corporation, this platform had previously only appeared as conceptual models and static frames at air shows. A maiden flight is more than a technical formality. In the world of aviation technology, it is the moment where theory meets reality. Designs are tested, stability is at stake, and long-held assumptions are put to the test. This drone is not designed for dogfights or high-speed chases. It is engineered for endurance, long-range vision, and above all, to remain undetected. Design and philosophy. The intellectual conflict. By design, this platform utilizes a high aspect ratio flying wing configuration. There is no conventional tail, no unnecessary protrusions. This configuration enhances aerodynamic efficiency while simultaneously minimizing radar cross-sections, RCS, from various angles. The air intakes are positioned on top of the fuselage. The engine nozzles are semi-recessed. Even the smallest details, access panels, landing gear doors, and structural joints are engineered for a single purpose: to reduce the radar signature to the absolute minimum. Fact versus interpretation. Endurance over speed. This design provides a crucial clue. The platform does not chase high speeds. Its focus is endurance, range, and silence. This means its role is not at the front line of kinetic combat, but rather to be the first to arrive and the last to leave. In many modern scenarios, information is more valuable than destructive power. Operational capabilities. In simulated demonstrations, this drone is depicted as capable of long-endurance patrols. Once a target is detected, data is transmitted via communication links to a command center. This data can be utilized for situational mapping mid-course, guidance long-range, precision targeting support. The onboard sensors include optical and infrared systems, enabling 24/7 operations even in complex weather conditions. Strategic impact and evolution. The presence of such a platform fundamentally alters the sequence of aerial operations. Before manned aircraft move, before other systems are activated, this eye is already there. It is inconspicuous. It does not provoke a reaction, but it builds a comprehensive picture of the operational theater. In information-based warfare, those who understand the situation first control the tempo. It is important to note, this is not about a single platform. It is about the evolutionary direction of unmanned aerial technology, transitioning from drones that merely scout to complex systems integrated into an information network, from supporting tools to key nodes in a modern operational ecosystem. The meaning of the maiden flight extended. This maiden flight is a vital transition from the development phase to real-world aerial testing. For years, this platform existed only as a concept or animation. Now it is airborne, testing whether paper designs can survive the rigors of a true operational environment. In the aerospace industry, this moment is the great divide between a promising design and a system truly viable for further development. At this point, engineers no longer discuss ideal specifications. They discuss the aircraft's response to reality. How do control systems perform during turbulence? How is stability maintained during changes in the angle of attack? How does the structure react to actual aerodynamic loads? The success of this initial flight phase is a primary indicator that the concept functions as intended. The stealth logic. The high aspect ratio flying wing is not an aesthetic choice. It is the result of a long compromise between aerodynamics, efficiency, and stealth. The high aspect ratio allows the drone to generate more lift with less drag, resulting in efficient energy consumption and longer loitering time. Simultaneously, the flying wing shape minimizes radar reflection angles. There are no vertical surfaces to easily bounce waves back to the source. By placing air intakes on the upper fuselage, the drone reduces direct exposure to ground-based and forward-facing radar. The semi-recessed nozzles suppress both infrared and radar signatures. The technological dimension. Systems over platforms. In modern development, a drone is no longer viewed as a standalone aircraft. It is positioned as a node within a larger ecosystem. This implies that the platform's primary value lies not in its physical form, but in its ability to interact with other networks. Control systems, data links, and software architecture have become as critical as aerodynamic design. Without robust integration, even the most stealthy platform remains a passive data collector. However, when networked, every piece of gathered information can be instantly processed, shared, and utilized in real time. This represents a fundamental shift in how aerial systems are evaluated. Flight test perspectives, defining success. Initial flight tests rarely focus on peak performance. Their objectives are far more foundational. Engineers seek to verify if the system meets minimum operational expectations. Does the autopilot maintain stability across various flight phases? Does control response remain consistent as speed and altitude fluctuate? Is the communication system stable and free from significant interference? Success at this stage does not imply that all challenges have been overcome, but it establishes the essential foundation for more complex follow-on testing. Without this baseline, subsequent development phases cannot commence. Stealth characteristics beyond geometry. Stealth is often misunderstood as being solely about shape. In reality, geometry is only one layer. Beneath the surface lies a combination of materials, specialized coatings, and thermal management working in unison. While the airframe design aims to deflect radar waves away from the source, radar-absorbent material, RAM, functions to dissipate any remaining reflected energy. Simultaneously, thermal management is vital for suppressing the infrared signature. This explains why high speed is not always the primary objective. High velocity often generates high heat, which increases visibility. In this context, thermal silence is as critical as radar silence. Positioning in modern concepts of operations CONOPS. Platforms of this nature rarely operate in isolation. They are designed to pave the way, rather than complete a mission single-handedly. In most scenarios, their presence precedes other systems, gathering data, filtering information, and providing context. This allows subsequent decisions to be made with more measured risk. This reflects a major shift in aerial warfare philosophy, moving from a reactive approach toward a data-driven, predictive one. Acknowledging limitations. It is equally important to recognize inherent limitations. Every design involves compromises. Lower speeds necessitate a higher reliance on stealth. Long endurance demands highly precise energy management, and network integration requires robust cybersecurity. However, in technological development, acknowledging these limits is a strength. It demonstrates that the platform is designed for a specific, clear-cut role, rather than attempting to be a jack of all trades. Long-term implications. If these trends persist, we will see an increasing number of unmanned aerial platforms focused on information intelligence and management rather than direct engagement. This has the potential to reshape resource allocation, mission planning, and risk calculation. In the long term, air superiority may no longer depend on having the fastest platforms. but on possessing the most adaptive and high-quality network. Conclusion: the invisible decider. This maiden flight may seem simple. A plane takes off, flies, and lands. But beneath that simplicity lies a much larger message. The future of air dominance is no longer determined by who is the fastest or the most aggressive. It is determined by who can see earlier, understand deeper, and endure longer. In the modern sky, the eye that is nearly invisible is often the one that decides everything.